Yeah, more detail. What do you mean by that? Detail means what? Detail in terms of what? Correct number of the building height. You still get the building height, right? You can DSM. You still get the building height, right?
How about DBM is like the cutting is more precise.
The cutting is more precise. Okay, yes. The answer is over there. Okay, so as you can see, DN usually is a raster. Is a raster format data. So and then DBM is usually not a raster data. It's usually a vector data. Right? DBM is usually a vector data. And this is usually a raster data. And so, in this case, DSM, so you guys know it, DSM is also usually DSM is also usually a raster data. It's also usually a raster data. But as you can see from this may not be very beautiful graph, as you can see, this red line I try to use to indicate the DSM. As you can see, it's the raster data. So the age of the building, as you can see, the corner of the building is not able to be captured precisely by the DSM. However, it can be captured or described precisely by the DBM because it's a vector data. So a line is a line and a polygon is a polygon over there. A raster is just pixel and pixel. So you may have something like this. For example, like this. You can maybe just use something like that. Right, you may have something like this to indicate the, for example, the red is the building top and the white is the ground. So in this case, the raster data can give you this type of pixel age, pixel ages. So this cannot be used to describe, for example, if the correct building age is something like this, or is something like this. So the DBM can give you a very precise, clear-cut age, but however DSM cannot. So in this case, when you use the DSM or the DBM, DSM is the only, or DBM plus the DEM, then in this case, the DBM plus the DEM can give you a more sharp age of the rooftop. But however, if you only consider like the DSM, then you will find out the age of the rooftop is like distorted. It's distorted because you have the behavior like this. So you have the distorted rooftop if you only use the DSM. If you only use the DSM. Okay, so that's a side story discussion. The reason I talk about that is also related to what Zheng Yong presented this morning. Because if you only, for example, if you only have the DSM, then the result will be if you perform the true also verification and then you only use the DSM, then the rooftop will be distorted a little bit. But so in this case, if you have the DBM, then the image can be corrected very perfectly. All right. So what supposedly? Okay. So in this case, let's go back to the topic. So right now, if we use the DEM plus the DBM, so which means that for this big point, what we can get is this location. So instead of getting this this point, we will extend it to this B plan point. We will extend it to the B plan point over here. and which means that we can also reproject it to the image to get this point, B1 point. And as you can see, if we can get the elevation, if we can get this B1 point, then after we reproject it to the image, what's the information over here? It should be the information of the rooftop. It should be the information of the rooftop. And that applies to any other pixels over here. Any other pixels over here. So you can reproject it to get the rooftop and then reproject it. So which means that if you have the DBN, then all the pixels within this building range, they can get the correct elevation. And then you can reproject this range of the pixels back to the image to get the correct building rooftop. And then those building rooftop information will be filling back to this region. So which means that if you have the DBN, then the building rooftop can be corrected to the location that is supposed to be. Okay? So in this case, here is the true also image. Alright, true also image. So in Chinese, you will usually call 真实真设, or usually we will just call it 真实真设, 真实真设. Alright, so the difference is that, as you can see, the general, the traditional, if you only consider the yen, the building rooftop is over here. So the B point will get the side of the building. But for the same point of the B is supposed to be here. Right. So this B point is the B1 point, you can say B1 point, the same point actually. So the building rooftop can be corrected to the location. Right. The building rooftop can be corrected to the location that is supposed to be. So as you can see, the rooftop is over here. Okay. Till now, any question? Okay, so these are actually something I tried to tell you last time, but however I don't have that much time, so I'm afraid you didn't really understand it, so I repeat it again this time today. Okay, so if you can understand that, then let's move on to the next thing. So gradually, as you can see, we need to process this pixel, and this pixel over here, that's just coded point C. As you can see, it's not a building pixel, however, is on the side of the building. So if we want to understand the elevation of this point, then we will go to the DN and get a point C. And after that, we can reproject the point C to the image. And to get this C point, what's the information that we stored on this C point? Lisa, what's the information we'll get here? The rooftop, right? So we will get this point actually. So this is actually the information stored in C. So this is the point. This is the information. So as you can see, the C point, where exactly that is? For example, the C point may be over here. So this is the point C. This is a point C. So originally, if we with the general authorization, of course, you will get these, you will get the rooftop information. But right now, even if we use the DBN and also the yen, as you can see, we already get the correct elevation of the C point, but however, after we project it, we still get the rooftop information. So which means that this C point over here, this is the C point, it still gets the rooftop information. So if without any other process, we will directly fill in that rooftop information to this pixel. And the true also image that you will get, it look like this. It will look like this. So as you can see, the rooftop is corrected to the correct location over here. But however, the rooftop will appear again for this covered region or for this occluded region. So let me circle it with the red color. So this red region, that is the occluded area. This is the occluded area, or this is the area occluded by the building. Occluded by the building. Occluded means 遮蔽，被那个房屋遮蔽的区域。Okay, it's occluded by the building. So so as you can see, okay, so this is it has a name called double mapping. Double mapping. So this type of behavior that the building rooftop appears twice, that is called double mapping. So as you can see, if right now I have one image and then this image is when it goes through the true also replication, and I give you the true also image, and supposedly in your mind, you will say, okay, this is the true also replication. It's even better than also replication. But so supposedly this is the perfect, the best product I can get. Then after you open this image and then you see, okay, why the building rooftop appears twice? So then you will feel like, what the hell is that, right? So in this case, you are going to think the whole process has a problem. But however, that is not a problem. This is because of this behavior. So you have that. Then let's come back. So in this case, this is a wrong information. This is a wrong information. If you are transforming the central perspective projection to the orthographic projection. So this is a wrong information. So we have the duty to find out where is the region that has the wrong information, and then to exclude that region. So how to detect the occluded area becomes the next question, and which is also the most important question when you are performing the true also replication. Okay, let me repeat my question. The detection of the occluded area is the most important procedure in the true also replication process. So how to detect the occluded area? How to detect the occluded area? One hint, we don't need additional data. We don't need any other additional data. The current data set is enough already. How to detect the occluded area?
Each fragment started with an RNA primer.
All right, think about this.
DNA polymerase that adds a short flow of DNA bases in a 5' to 3' direction.
Eugene, any thoughts? Really?
The next
Any
time
thought?
is then added further down the lateral
So-
strand.
The whole surface
Another
area
exactly fragment is then
minus
made. And the
the
process is
appear area,
The whole what area?
whole surface area of the,
The whole surface area. Surface area.
yeah.
The DSM area. That's what you mean? What do you mean by whole surface area? 表面积 the area size of what? Of the building and
Minus the appear area in the image.
minus the appeared area in the image. What do you mean by appeared area? But even if you have the number of the area differences, how can you tell the location of the occluded area?
Yeah, I still wondering.
Okay. Okay. 没错。Any thoughts?
Maybe compare the DBN data with the image first. To
Compare
find out that that location isn't it is a building or just a surface from
You mean compare the building DBN
with
with
the image.
and then to know what?
The maybe the difference between them.
The difference.
Yeah.
One is in the object space, one is in image space.
Yeah.
So how do you mean by the difference between them? Yes, actually, you guys should focus on this. Yeah, you should focus on here. Actually, you guys should focus on here.
Different location.
Yeah,
Maybe
what the direction that you are pointing at is correct, but what exactly are you saying? Are you trying to perform over here?
just compare the image and DBN.
How are you going to compare them? Like I said, so are you are going to reproject that or something? Because right now, first thing is one is in the object space, one is in image space. So you couldn't compare them directly. So either you the only solution you have is to reproject what you have in the object space to the image space, so that you can try to compare something. Any thought? Yes, Inzo.
Ground control point?
Ground control point. You don't need ground control points. Like I said, you only need the information here. The information that you need is DBND and EOP. That's all the